everyone, this is just a quick video to help walk you through how to analyze standard curve data and interpolate unknown samples from that data. Feel free to follow along with your own data and pause and rewatch as needed. There's going to be 4 steps that we go through to analyze this data. The first is we're going to blank correct. The second is we're going to check and average our triplicates. Then we're going to plot absorbances against known protein concentrations to get our standard curve equation. And then we're going to interpolate our experimental data. I'll show you 2 different methods we can use to do that. And at that point, you should account for any dilutions if applicable. So if you diluted your samples in order to have them within the range of the standard curve, by the time you're reporting that data as a result, you should have already, during this analysis, accounted for those dilutions. So here I've just got some imagined data. This is our triplicates going across in the rows. We have our standard curve, including a blank over in these 3 columns. And then these are the data for our unknown samples. We have 3 different samples, and each one has been run in a technical triplicate. So if we follow along in our steps outlined at the top, the first step is going to be blank correcting. And the first thing I'm going to do in order to blank correct is I'm going to find the average value of the blank. Okay, and I'm just going to shorten that number, and so this is now the average value of my blank that I'm going to subtract from every value that appears on the plate. So I'm just going to start with doing this to the curve. Let's concentrate on that for now. So how I'll do that is I will say each of those values minus always that average blank value. I can then take that formula and paste it everywhere, double check that it's doing the correct calculation, and that all looks good. So the next step that we have to do is check and average our triplicates. So I just set myself up a table to do this, and the way that I'm going to check my triplicates is to find the standard deviation. And I'll just do that for all of them. That. And then I'm going to find the average. Okay, once you've checked that your standard deviations are within an acceptable range and you've calculated your averages for all of those values, the next step is going to be to plot the absorbances against known protein concentrations. So I've just taken these known protein concentrations. This particular standard curve was prepared from 2,000 down to 25 micrograms. And I've just taken these average values that I have from finding the means of the triplicates. I'm going to now plot these data like so. Okay, I've just formatted the graph a little bit so that it looks how I want, and now I'm going to add a trend line. When these options pop up, I'm going to click Display Equation on Chart and Display our squared value on chart. And what this does is this gives me my y equals mx plus b equation that I can use to interpolate unknown data using this linear relationship. And it gives me the r squared value, which allows me to evaluate the strength of this linear relationship. So a value of 1 is a perfect linear relationship, and anything close to that is indicative of the strength of that relationship. The next step is going to be using that linear information to interpolate my experimental data. I'm going to go through 2 different methods of interpolating our data, but first let's get that sample data down here and we can check the variability of the triplicates and get their average value. So here are the triplicate values for each sample that I had up in the original table. I'm going to check the triplicates by finding the standard deviation. And then if everything looks fine with the triplicate values, I'm going to use all 3 of them to find my average value for that sample. The first way that I'm going to show you how to interpolate your unknown data is using the y equals mx plus b. Now this equation can be rearranged to be x equals y minus b from this equation, all divided by m in this equation. And you can repeat that same equation for your other unknown samples. At this point, you should be incorporating any dilution factors that you had used. In this case, these samples were not diluted, so my dilution factor is simply 1. But if you had done a 1 in 2 dilution, that would be a 2, a 1 in 10, you'd multiply by 10, and so on. And in this case, all I have to do is multiply by the dilution factor of 1. The other method of interpolating unknown data that I'll show you is using the forecast function. So in this case, you can interpolate by forecast this value considering these values lead to these values. And now I want to make sure that my forecast is always reading from the same information when I change to different unknown data. And I'm just double checking that I'm reading from there and then from there, but always back to these same values. So as you can see, the data that you get from interpolating using these two different methods is not identical. It's close, it's very close, but it isn't identical. And so the choice of which to use is really up to the researcher. I empower you to read about each type of data analysis and determine which you think is best for you. I have used both of these for different situations in my experience. Again, if you have any dilution factor to incorporate into those data, you would at this point multiply your value by the dilution factor. So those are the two methods that you can use to interpolate data from your standard curve. And I'll just leave you with a couple of closing thoughts. So number one, make sure you use an appropriate method for your data set. Like I said, you can read about the pros and cons of each of these methods and decide what's best for you and your data set. It is most important that the replicate data that you're using is reliable and accurate. So again, make sure that you actually do check your standard deviations of those triplicates. There's a reason that we do triplicate. If there's something strange about one of your replicates, we can discuss what to do with it, whether you want to exclude it, and that kind of thing. Do check your R-squared value. So if you have a poor R-squared value, again, 1 is perfect. Close to 1 is great. It is possible that you can drop points of the standard curve, provided that they are not encompassing the range of the curve that your data will be interpolated from. So if there's something really strange about the very top or the very bottom, for example, but all of your data that you're interpolating is through the middle, then it is possible to drop points of the curve. That's it for this tutorial. Hopefully you found that useful. Again, feel free to follow along with your own data and just work through it at your own pace. Any issues? Come and see me anytime.